Okay guys, so we're going to be doing the file IO task, and in this task I'm going to make it a kind of series. And I think we have so far we have just how many tasks we have, just 5 tasks, so we're going to have 5 different videos for these tasks. But the first task, we're going to deal with the quiz and then task 1, right? So yeah, so go through the resource. I'm not sure if this file descriptor is very helpful. This one would probably I think give you more insight about writing things into a file and all those stuff, right? And one thing you should know is that, okay, this one is from the last class, so let me just delete it. So one thing you should know is that why why do we need file, right? Why do we need to create file? Why do we need to write in a file? When you do your normal program, when you do your normal execution program, right, you will notice that, for example, if you have /main.c, right, and you give it some command line argument like 2 plus 3, right, and it returns probably 5 for you, you will notice that by the time you come back, maybe you turn off your system and you come back, these 2 and 3 would have been wiped out of the memory, right? You can't call them back, right? So sometimes you will need to save something in your system hard disk so that you can call them back. Because of this, you need something like a file, right, which will be saved on your hard disk. Because when you are running a command like this, that command is being run on your RAM, right? So it is run temporarily, and then it is being freed later on. Okay, so basically this is one of the reasons why we need file, right, in a program. Okay, so additionally, you have to know this. So if you have a file, right, if you want to view what is inside that file, you want to read it, you have to open it first, right? And when you finish reading, right, you need to close it, right? So if you want to write into it, you need to open, and then you need to close at the end. If you want to append, you need to open, you need to close, right? Good. So we have this other function, read and write. So I'm just going to I think man2 read, right? So if you look at it, it is defined in the unistd, right, header file, and then this is a signed what is it, integer, right? This is a sign, that is, it can be minus, it can be positive, right? So it returns a signed integer, right, which is this I think count, right? So it returns this guy. So fd is what, if you look here, file descriptor. So if you, in the beginning we have file descriptor, you see it here, right? So that's the file descriptor, fd is always an integer, right? So it is either, it is 0, which means standard input, 1 standard output, right? So our fd can be 0, which is standard input, right? It can be 1, which is standard output. It can be 2, which is standard error, right? So it can be all these things. I think we even have 3 and it can, I think it can only be positive, right? So basically they are majorly positive number for file descriptors, right? So this one take in this parameter, a file descriptor, right, a file descriptor, and then a buffer. This buffer is, as you can see, is a pointer, a void pointer to probably you want to store strings and stuff, right? And then this one is the amount it needs to read, right, out of this buffer. So this buffer can contain a lot of things, but we can say, okay, I want to read just five character out of all these all these words that this guy contain, right? So read in itself collects input from the keyboard, right? From standard input, right? It collects input from the keyboard. You like this. Where's my, okay, this is my terminal. So let me just queue. So like for example, like saying, let me say doing ls, right? All these things, they can get stored inside read. Read will hold them, and then you can use write to display them to the output, right? So basically these are some of the things that these guys do. Read and write, they are almost defined the same way. Write also is defined in UniSTD. They contain all the system calls, right? All system calls are defined in this UniSTD.h, right? So read is a system call, as so as write. So let me see if man2 write. I'm not sure if it is man2 or normal write man. Okay, as you can see that it's for write as well, it is almost the same. Define descriptor, we have a void constant, and then it's return. Remember that when you are using write, you have a zero, you can have 0, you can have 1, you can have 2. That's the file descriptor, telling you it is standard input, standard output, standard error. Okay, you have your words here, right? And then amount you want it to print, right? So that's how write is too. But for write, it is just a bit different because the command is coming in, and then this one is majorly going out, right? So write up to count byte from the buffer starting at buff to the file referred to by the number of bytes written may be less than count. Okay, if for example there is insufficient space on the underline, I think this one is talking about these guys and this guy, right? So do well by reading all these man pages, right? So read them, and then I think it will help a bit. Okay, so dprintf, I didn't really check this dprintf. I know of fprintf and normal printf, but let's man dprintf. Okay, so dprintf, look at the dprintf. So it takes file descriptor and then format, just like I think it's still like to print formatted output, right? But the only difference is going to collect, is a standard error, standard input, standard output, and then it's still normal printf format, right? Which is a constant character, and then you can do your normal stuff here. I think for fprintf is going to collect the file pointer and then do this, right? But for this one is printing to error, right? I think that's the difference between them. Okay, so basically that's a bit on that. It's good that we read through that. So said you can go through all this. I think open, close, read, write, we've talked about that one. So this one, these flags, I think this one is read only, read and write. This one is read only, this one is write only, right? Or are, right? So all these things are necessary. You read about them. Okay, let's go down a bit. So the write is a, like I said, is a system call, right? Because it's defined in even UniSTD, and system calls are those functions, right, that they communicate directly with the kernel. Okay, they communicate directly, like they don't go from one place to another, right? Before, it's just like you want to probably order some groceries, right, in the store, and then you want to order some groceries in the stores, and then probably you want to order, let's just say you want to order some carrots, let me say carrots, right? You go through a mobile app, right? You go through a mobile app, and then probably they then deliver it to you. But for system calls, from carrots to kernel straight, and then probably this guy will go to the kernel, and then right. So for system calls, they interact with the kernel directly, no intermediate, right? And then the kernel is the one responsible for performing all the works that you're doing on your program, right? So basically that's and then they are executable, right? Okay, and then we have the second one. When I am using write only, I think this one is create, I'm not sure, and then this one is append, right? The dash are bitwise operator. Okay, this one are true. Why always ask why? I think this one is just a random question. Why always? Okay, because most of the time I will already have standard input 0, standard output 1, standard error 2 opened when my program starts executing. Okay, I don't really understand this question, so if you understand this, you can drop that on the comment section. But I just picked this and it worked. So we have this. What happened if you try to write best to the standard input? Okay, standard input on Ubuntu. What happened? The text will be printed on the terminal on the standard. Yes, because when you try to use the read, for example, right? It collects from standard input. When you type that thing, it's going to appear on your terminal. It's going to appear on the terminal. Okay, so okay, they say tips, just try it, okay, and see what happens, right? Try it and see what happens. So what is the std symbolic constant for the standard input? As you can see, standard input, right? File number. And then this one says most of the time on a classic modern Linux, you will be the value of the first file descriptor you get after opening a new file with open, if open successful. So like I said, that file descriptor doesn't just end with 2, they continue, and then there are some that when you open the file descriptor is 3, right? So this one says which of these answers are equivalent to read. I think this one I use Google to actually check this guy out. I'm not too certain because I haven't really gone through this what's it called, this O file, ZO file, your code. Let me see. Okay, when we get there. So basically the answer is 3 and 2. This guy I think I used there's this website to get this answer because directly, but basically this one is all wrongly. It means this one is standard input, right? Redirecting it to all wrongly, right? Read, right? And then read only is directing standard input to read only, right? And then 2, standard error. 3 and 2, I'm not sure of this guy. Yeah, something like that. I'm not sure of this guy. And then we have 1 redirecting to 1. Use printf or read the header to see the definition value of these macros. Okay, I think most of them have some macros. Okay. Okay. So I think the macros, all these macros, I think all these ones are macros. So let me see. the definition of all these macros are going to be their macros, and then they have some definition. So you can check on macros or read only or write only, like that. Okay, check on what they mean. So this one might just be one, right? And then it's going to be even equivalent to this, like that. Okay, so yeah, O flag is what I was saying. So what is the O flag used to open a file in mode read and write, right? So read, write, right? Read and write, as you can see. Is open a function or a system call? It is a system call, like I said. Open is a system call. It is a function as well. It's a function provided by the kernel. Like I said, system call are always kernel interactables, right? So what is the current combination of O flags used to open a file with the mode read only, create if it doesn't exist, and append new content? As you can see, this one is read only, right? Create if it doesn't exist. So these three are going, and append only, right? So these two matches, but this one is not sorry, for write only. So this one is not write only, right? So this one goes, right? So I think these ones are macros, and then we'll just try and check them out. I don't know, maybe in the next video I might just quickly go through that. I might have just check it out, right? So what is the UniSTD symbolic constant for standard error? As you can see, standard error, right? So all these things are macros. What is the O flag used to open a file with the mode read only? As you can see, RD, read only, right? So all those O flags, we check them. So what is the return value of a system called open if it fails? So when you use open returns -1 when you use open to, like I said, if you want to open a file, you use you have to, if you want to write or read a file, you have to open it first, right? So the open would return -1 if it is unable to open that file, right? If you use open to open a file, open collects a file name, and is it there's one more parameter. Let me see if I can see it. Man open open collects the file name and a flag, right? I've forgotten what's this flag. Yes, the flag is either you want to read, you want to write, and then you want to append, right? So it takes that. So if you cannot open that file, it's going to return, as you can see, int. It's going to return -1. Okay, so let me quit this and go back, right? So what is the unit symbolic constant for standard output? As you can see, standard output, right? And what system call would you use to write to a file descriptor, right? File descriptor, remember, is either we use where's that guy? Is it pprintf or dprintf rather? Dprintf, or we use write, right? So write also collects file descriptor as one of its parameters, right? So basically it's write, because write, we can use write to write to our standard input, to our standard output, and to standard error, and these are file descriptors, right? So let us see what we can do to this task and go through it. So the first thing I want to do is I will create the directory. Create my readme. It's been long we used Emacs. Let's place this guy there. Okay. Hope I'm right. I think we overdid it. The script. Okay. Alright, good. So the next thing is what are those executable? Okay, they are still ABC. So let's create this is our 0min.c. So I think we going to 0x05 file descriptor and permission cat. I think we're going to have this file called resicat, right? So we're going to have this file called this. So I think that file is what we want to work on, and then it's going to have all these things up to this point. So one thing you should know is that at the end of the file, it is called end of file, EOF, right? End of the file is called EOF. So let me escape this one. So that one is just to test. Let me clear it and ls. So I'll vi my main.c as well. So we have, so our header file will be main.h, as you can see it here. Okay, 0 main.c, 0 read text file.c. Okay, is this a command line argument? C and V, I think so. It is a command line argument. I'm wondering what this okay, no, they're just executing it here. Okay, this one is the execution and what it's going to print out, right? Yep. So this is our solution, right? It's going to return, I think, number of character we have there, or number here. So vi 0 main.c. So leave that one. So I think I saw something in the compilation. Okay, I think this one is the file name we'll be creating. Okay, because I was scared. What's that? Okay, so let me just write the file. So this is the file. Don't forget we have a main.h as well. So let me just create this one. So I'll vi my main.h. Okay, so I'll sorry, if not define, right, define, and then end if, right, good. Okay, so what else do we need here? We need a prototype. We need a prototype, Sorry, oh. Good. So we need some header files, right? So I'm going to include uni.std.h for our open and close and all, right? So we'll need that. We'll need our standard library because we might be using malloc, right? Standard library.h. Good. So there's these three functions that we'll be using, right? So we have three other functions that we'll be using. Okay, so the first one is the include system types.h. I think something like this. Okay, so this header defines various basic data type and structure that is used by the system, right? So it provides the function for this SS size, right? That's signed size T, right? So it's the one that provide functions for that. Okay, so we have another one, include system start.h. So for this one, system start.h is for structure start. I think we'll do that later on. And then the last one which we'll need is for those macros, those o wrongly, o read only, that we still need to check later on, which is include I think function control, yeah, control like that.h. Okay, and I think we'll be good this way. So with this we have 1 2 3 4 5 and then header file. Okay, so and then let's go into our code. So we have this, so vi our 0 read text file.c. Okay, so we'll include, remember we've not read our question, we don't know what we want to do yet, but these are just the normal thing that we need to do, so you can skip forward, probably that's too late now. And then so we'll have our this guy again, so let me just paste it here, go up, come down. So we'll have our read text file, read underscore text file. So that one is supposed to, what is it supposed to do? So write a function that read a text file and print it to the POSIX standard output. Okay, so it's going to print it to the standard output. Forget about this POSIX for now. Let's come there. This thing is too long. And print okay. So I'll just do it from here and print it to the POSIX standard output. Okay, so the next thing we have is our file name. As you can see, is a pointer, right? Is the file name, but is a pointer, a string pointer. Right, and then we have our letters, and this one should be number of letters printed. So we'll have a return definitely. So this guy, as I said, can return negative or positive numbers, okay, but it's going to return number of letters printed. Okay, so let's go to the question now. All right, so basically if you look at the question, we have our prototype, we typed it, right? Write a function that will read a text file. So you are going to pass that file to it. It's going to read in that file and print it to standard output. Okay, you are passing a file to it. So this is the file name, right? Above a pointer to where the file is located, right? It will collect that file name, collect the content, which is the content of this recluse cat, right? And then it would what was it? This guy is the how many do we want to print out of this file name? How many things do we want to print out of this file name? Okay, and then it should return the number of letter it could read and print. Okay, so how many guy this guy printed is going to return, right? How many printed? Okay, if the file cannot be opened or read, it should return 0. If the file name is null, that is the file is not existing, it should return 0. If write fails, so write is the one we will use to print it to the standard output. We'll use read to read the text file, right? Collect it. Okay, or does not write the expected amount of byte, it should return 0. Okay, so let's see. So basically you can just sketch out different things for this guy. There are so many things to do. Okay, so for example, since we'll be using read and write, and you know that read and write, they collect file descriptor, they collect a pointer to a probably string, right, of character, like a buffer, right? And then how many do we want them to print? Okay, so and they return signed size t. We've defined what the header file for that. So we have int, the file descriptor, it can be 0, 1 or 2, right? Enter. We have the size s size underscore t, right? So so this one is the number that it will read, number read, and number written. Okay, yes. Then we'll have our character. This character will be the one in the middle of that parameter. That's how many, the strings that we want to collect from this file, right? So the read will help us put that, collect anything the person from that file. It will collect it, store it. Write will push it out. Okay, so we have a pointer to a buffer. Okay, to a buffer. Okay, good. So the first thing is, it says that if our file name is null, right, it should return 0. So there are so many. You can say if file name equals to null, return 0. You can say if not file name, okay, that is, it is not that particular file name, it should return 0. So we've done that, right? Good. So what happens if it is the file name? We open the file, right? Open returns a file descriptor. Negative if it cannot open the file, right? I think we talked about that briefly, that if open cannot open it, it will return negative number, right? If not, it will return positive number, okay, or 0, I guess. So we'll say fd, which is our file descriptor, will equals to, let's open that file. Open collects 2 arguments, right, which is the file name. I don't know if I should put it in the quotes, file name, and then comma. What do we want to do? We want to read the file, okay? So we say read only, okay? So we want to read the file. That's what we'll do. Enter. So then say if our fd is equal to what? -1, it should return 0. Why is it returning 0? Because if what this guy return, we don't need this equals to fd, okay? But if it is int, so it means that I can stay negative and positive. So we can just open the file, right? But they said if it does not open it, then it should return -1. So when they are testing our file in the back end, when they are testing our function, they might be using some main that would have different file name, right? That does not exist in their own probably shell or sandbox or anything, whatever. So that's why you will still see some checker failure of outputs, because the main they gave you is not what they are using to check your code, right? Okay, because they know that if they're giving you that main, you would probably maneuver it. Okay, so if fd equals to -1, you should return 0. Why? Because if this guy returns -1, it means that it cannot open that file. If not, let's continue. If not, we want to use, if it has opened it, right, then we want to use write to collect whatever the input, whatever it's passed through it, right? So if not, I'll do something here. If not, let's say write, right? So let's say read. We want to use read to read, right? If not, we would use read, right? So read will collect file descriptor, right? It will collect that string, the buff, right? And then it will collect how many do we want to read. But before that, it will return how many it's what's that thing? It will return actual number of letter it's read and print. So we'll pass that letter to NRD, number read. Okay. So before that, buff, we've not allocated memory to it, right? Because we don't know how many things will be passed. Character can only save one byte, right? So we need to allocate memory for buff so that it can contain a lot. We don't know how many stuff is coming in. So before we use buff, we would allocate memory here, right? So we'll say buff, right, is equal to, then we'll allocate malloc size of character, right? Size of character times how many thing is coming in, letters, that's the amount coming in, and then we'll say, let me give this one space here. Then we'll say that if our buff is equal to null, right, it means it's not allocated, or if not buff, right? So you can say if our buff is equal to null, right, it should return 0. So you can say if not buff as well, right? So and then I had the call. Okay, I have cut the call. So what else? What else do we do? This call has disrupted my. Okay, so read would return the amount, right? So buff is the amount of this guy, right? Letter is the amount it wants to read. File descriptor, right? Okay, so one thing I'm looking is we have not initialized this file descriptor. Let me see. Is it going to take? Yeah, it's going to, I think it's going to carry on from what this file descriptor is. If it is not -1, it's going to be probably 1 or 0, right? And then we'll carry on that way. Okay, so the next thing is read has collected that items, right? So now number written equal to, so this thing is almost the same thing. Then we'll do write, and you know how to use write function. We'll have 3 parameters, right? So we'll have our buff, definitely, comma, we'll have how many do we want to write out. It is NRD, right? This number is what we want to write out, right? And then before that we'll have one more guy, right, which is this standard output, is this standard error, standard input, standard output, right? So here we would say standard out, right? Standard out underscore. So these macros is something we need to take a look at. So at the end we then say close that close the, what's it called, the file, and then we'll pass on the file descriptor, and then at the end as well we'll free the buff. Hey, my light is off. Oh, let me turn on this light. So we'll free the buff. Thank God I'm just doing this one, if not this NEPA people would have. And then we should return. I need to on my lights. Okay, I've seen it. Please hold on a second. Okay, good. It should return the number it printed, right, which is NWR. I think this guy can still be NRD itself, so you can try that and see if that will work. I don't know if this code will work anyway, but let's see. I think we are good like this. So let us Betty O read. I'll be careful because I'm not adding git ignore this time around. I'll be careful not to push all those other files. Okay, no description file for parameter, file name and letters. So let's go back inside and see file name Didn't I write it well? This thing has start again. Let's see. It has started again. Again. Oh, sorry. I'm the one that started again. I'm supposed to put at here. Okay, so we are good with that, right? So let us see if our compilation will work on this guy and see what will happen after compilation. So if we look at our main file name, let's see, does it has anything like the file name? Okay. When we are, it is a argument to main. So I was looking for this guy to see if it is inside or outside. So it's outside. So let us see. Oh, okay. We have one error. Buff at 29 space as well. Where is it? Buff. Where are you? Yeah, I've seen it. So F. So we do like this. It compiled A, and what's that guy called? P something. Oh no, R requisite. Let me see. It didn't auto complete it for me. Yes, thank you. 468. Right, so let's see. I think that's the main thing that we need, 468, and here we have 416. Good. So clear. ls. So if you want to add now, I'm going to just add my main.h, and also I'll add my oread. Right, which other one? I'll add my readme. Where is readme here? Okay, no requisite readme, man. Readme. So main requisite. So I'll leave requisite for now. Leave A. Leave 0 main.c. Okay. Then I will git commit with a message saying that it is to read a text from a file, or right, and then print. It will read it, collect it, and then print the letters read or something, right? And then git push, though it's supposed to return as well. So let's git push that. So this is the second deadline already, as you know. So let's check our code and see it work. Wow, congratulations, great. So basically that's it. If you have any question, let me know. And please, one thing is that I think I'm aiming towards 1K sub, and I'm trying to meet up that sub this month. So I'll be so glad if you can just eat it, even though you might not be interested. Just eat it for now, and I'll be grateful. So I think that's all for now. So the next one would be this one, and then we are to create a function that creates a file, right? It's going to help us create a file. So we'll dodge into it in the next video. See you. Bye.